Welcome back, Chemistry Theory. This is the last video in the MS2.1 section. So we're going to do these last two examples that I left you with. So Nf3 Nitrogen Trifluoride. So of course we have one nitrogen, 3 fluorides. Nitrogen is a group 5 element, so there's 5 valence electrons. Fluorine's a group 7, so 7 valence electrons. So we get a total of 26 valence electrons for there. And you can see this is very similar to the ammonia one that we've done before. Okay, extra electrons go on the outside F's. There we go. 2, 4, 6, 8. 8 times 3 is 24, but we have 26. So the extra set goes here on nitrogen. And we can do the formal charge calculation. So fluorine is group 7, and 1, 2, 3, 4, 5, 6, 7. There's 7 electrons involved in this structure. All the way around. Nitrogen is group 5, so it should have 5 valence electrons, and 1, 2, 3, 4, 5. It does have 5 electrons being involved in here. So electron domains. Let's see, we have, let me grab my pencil. We have 1 area, 2, 3, 4 areas where we can find electrons around that nitrogen. So we need to look at electron domain geometry and molecular domain geometry. So 4 domains, right? So 4 domains. And the electron domain geometry considers all 4 of those important, so that would be a tetrahedral shape. Tetrahedral. But if we look at the molecular domain, out of those 4 domains, 1 is non-bonding. So out of those 4, 1 is non-bonding, and you can see it does look like that. Trigonal pyramid or trigonal pyramidal. Trigonal pyramid shape. All right, so we have all that. Now we have to do is look up the electronegativities from the electronegativity chart. So fluorine, of course, we know that one. It's 3.98. So 3.98, so all the way around 3.98. And nitrogen is 3.04. Oh, so we know what's going to happen there. 3.04, so 3.98 minus 3.04. So that's going to give us an electronegativity difference of 0.94. And yes, that falls under the polar covalent range. So we know that is a polar covalent, and in this case we have 3 of them. 1, 2, 3. Polar covalent bonds pulling in every direction. So what we need to do is see, do these cancel each other out though? Let's see, do they cancel each other out? So it is a 1 non-bond. And oh no, they don't, because there's a downward pull in every direction, so it will be polar. Polar molecule. So we'll be polar overall because they don't cancel each other out. All right, let's look at the last one. BCl3, boron trichloride. So we have 1 boron, 3 chlorines. Boron is group 3, chlorine is group 7. So that's 24 valence electrons. All right, so boron, chlorine, chlorine, chlorine. Put these all in. The outer electrons go in the outer atoms. 8 times 3 is 24, so we're good. And if we do the formal charge calculation, there's 7 there, so we're going to be good here, good here, good here. Boron is 1, 2, 3. Oh, we're good. So that's the structure right there. So electron domains, we have 3 of them. So the 3 areas around boron, 1, 2, 3. So electron domain geometry and molecular domain geometry. So let's see, there it is, trigonoplanar, and there is 0 non-bonds, so it's going to be trigonoplanar as well for both of them. Trigonoplanar. Now, because the molecular geometry is trigonoplanar, we know that it's going to be non-polar. I don't even have to look at the polar bonds, but the question that I'm going to give you, say, prove that it isn't, etc., or what are the values. So what we have to do is still look up the electronegativity. Chlorine is 3.16, so 3.16, and boron is 2.04. Ooh, that's a big difference, isn't it? So 3.16, 2.04. So those are definitely polar covalent bonds. So we do have a pull in this direction. We do have a pull in this direction. And we do have a pull in this direction. Now this, how I drew this is deceiving because it looks like a T shape, doesn't it? But we know that it is actually trigonoplanar. Those angles should be 120, so I should have drawn it like that. So if you want, you could redraw it so that you can see that these upward pulls are bounced by the downward pull, etc. So just be careful with how you draw that. Look at this. Look at the actual shape, not how you drew it. So polar covalent bonds, but overall non-polar molecule. Okay, because they are going to balance each other out using this chart. So yeah, we have quite a few charts we have to use here. We have to use this one, the ones that the shape. We have to use the electronegativity chart. Okay, so you should be able to do the assignment, and we'll see you again.